All right, today we're going to peel back the layers of Bitcoin. We're going to uncover this simple, but honestly incredibly powerful language that makes the entire network tick. So let's just dive right in.
So what is this secret language? The one that powers every single Bitcoin transaction. It's not just a bunch of code. It's really a set of rules that gives Bitcoin its superpower as programmable money. So what's this hidden engine all about?
Well, to really get it, we've got to kind of shift how we think about Bitcoin itself.
See, here's the key thing you need to understand. Bitcoin isn't just digital cash. Not really. It's a system that's all governed by programmable rules for spending. Think about your bank account. The rules are fixed, right? But with Bitcoin, you get to define the conditions for spending your money. It could be super simple, like just needing your signature. Or it could be way more complex, like needing signatures from, say, 2 out of 3 business partners. You could even lock up funds until a specific date. So yeah, it's less like a dollar bill and way more like a tiny, super secure computer program that's attached to your money.
And what's just so brilliant about this whole setup is how it splits 2 really important ideas: authorization and authentication. So authorization, that's all about setting the rules for spending, like our 2 of 3 signatures example. Then you have authentication, and that's all about providing the proof that you actually meet those rules, like providing the actual signatures. This split, it's right at the heart of how Bitcoin's language works.
Okay, so this language, the one that writes all these rules and checks all the proof, it's called Bitcoin script.
And really that's what it is. It's a simple, stack-based language that was built for one reason and one reason only: to validate Bitcoin transactions. It's not for building websites or games or anything like that. Nope, it does one thing, and it does that one thing incredibly well, with just extreme predictability and security.
And this comparison here really drives the point home. You've got languages like Python that can build almost anything you can imagine, but all that flexibility, it brings a ton of complexity and, well, potential bugs. Bitcoin script is the total opposite. It's intentionally limited, it's simple, it's predictable. Every single computer on the network has to get the exact same result every single time, and that simplicity is what makes it all possible.
So you might be wondering, how does a language that's so simple actually process instructions? Well, it uses this beautifully old school and super efficient method. It really all boils down to 2 key concepts: a stack, which is just a simple list where you add and remove items from the top, and something called reverse Polish notation. So instead of writing 3 plus 5, you'd write 3, 5, OP_add. The numbers come first, and then the action, the operation, comes last. Let's actually see how that works.
Okay, so the script starts reading from left to right. First thing it sees, the number 3. So it just takes that number and pushes it right onto our empty stack. Simple as that. That's step 1.
Next up, it sees the number 5. And what does it do? It pushes that right on top of the 3. So now our stack has 2 items, with 5 sitting right there at the top.
And finally, the script gets to the operator, OP_add. Now, it knows this command needs 2 numbers to work with, so it pops the top 2 items off the stack, the 5 and the 3, it adds them together to get 8, and then it pushes that one single result back onto the stack. And that's it. That's the fundamental logic behind every single Bitcoin transaction.
Now, all this simplicity we've been talking about, it's not just for looks, It's not just about being elegant. Every single design choice in Bitcoin script is laser-focused on one thing, and that is ultimate security.
And there are just three critical design principles that make this language so incredibly tough and trustworthy. Okay, first up, it's turning incomplete. Now, that's a fancy way of saying it has no loops. And this is so important. It's a feature, not a bug. It guarantees that a script will always finish. That means no one can write some crazy program that runs forever and attacks the network. Second, it's stateless. The script has zero memory of anything that happened before. Every validation is a totally clean slate. This is what ensures you get predictable results everywhere in the world every single time. And third, it's minimalist. The language only has the absolute bare bones instructions it needs. And what that means is there's just less stuff that can go wrong or be exploited by a bad actor.
So, here's the big takeaway, right? In the world of Bitcoin script, these limitations, they aren't bugs. They are the absolute foundation of its security.
All right, so let's put this all together. Let's see how all these pieces come together to actually validate a real transaction. The best way to think about it is like a smart lockbox. When you get some Bitcoin, it's like it's been placed inside this box. The locking script is the set of rules that are kind of etched right onto the box itself. Something like,
This box can only be opened after October 31st and only with a signature from public key X. Then, the unlocking script is what the person trying to spend the Bitcoin provides. It's the keys, the proof that they meet those rules.
And here's how they actually work together. The unlocking script, over on the left, its job is just to provide the data. It pushes your digital signature and your public key onto the stack. That's it. Then the locking script on the right takes over. It's got the operators, the instructions like up_checksig that are going to process that data and check if that signature is actually valid for that specific key.
So the network basically combines these two scripts and runs them. And if, after all the operations are done, the one single thing left on top of the stack is the value true, the transaction is valid. Boom! The lockbox opens, the funds can be spent. If it's anything else, anything at all, the transaction fails. It's that black and white.
And this all brings us to a really fascinating final thought. You know, Bitcoin Script gave us our very first taste of what truly programmable money could be. It showed us that value doesn't just have to be passed around, it can be programmed with all sorts of conditions and logic. So the big question this technology leaves us with is this: if money can have rules, what are we going to program it to do next?